My name is Parth, and today we'll be going over a circuit from homework 4. This is like question 6, if anyone wants to know the reference. So this is like a double RC op-amp problem, and we have to find Vout1 and Vout2. Vout1 is this one, Vout2 is this one. Alright, we're going to start with Vout1. So now, we all know, sorry, there's a ground here. Sorry, I missed that. Okay, so now we know, first of all, so there's two rules. Okay, the first rule is the currents which are entering into the op-amp is always zero. This one and this one, they both are zero, and the voltages here and here are the same, so this is also zero. Okay, that makes it easy for us. So now we're gonna do a KCL here. Let's just consider this point as A. Alright, so we're gonna do a KCL here. So the current, so basically KCL means that the currents entering into the node equals to the current going out of the node. Alright, so now here the current is going from here, from point A to VI, and from point A to Vout1. That, alright, so we're going to do a KCL, and this is 0. So what we're going to do is we're going to do a KCL which is going to be like this. So 0 minus VI over this one. This one is 5 kilo ohms. Alright, so this is 5 kilo ohms plus this one. So this one we can consider like IC1. This is like capacitor 1, alright? So plus IC1 equals to 0. Alright, so we can write this one like this. Plus, and we know that I equals to dV over dt for a capacitor. Alright, we're going to use this one over here. So IC1, we can write this as dVC1 over dt equals to 0. There is like derivative of the voltage across a capacitor, which is this one, over dt. Okay, so now we need to isolate VC1, or first of all, VC1 is the voltage across the capacitor, which is 0 minus Vout1. Which is gonna be like this. Alright, so VC1 is negative Vout1. Alright, so we're gonna substitute that in this one over here. So negative VI over 5 kilo ohms plus D VC1. VC1 is negative Vout, so we can bring the negative in the front. Vout 1 over dt equals to 0. Alright, I hope you understand this. So now we have to find Vout1. So what we can do is we can isolate the derivative of Vout like this. Over dt equals to oh, we forgot a C here. Oh yeah, there should be a C in the front. Alright, my bad. So we need to isolate this, right? So we can move this and move the C on the other side. So it's gonna be like this. Times, and now we're going to bring the C on the other side, which is going to be like we can write negative anywhere, that doesn't matter, like on the in the bottom or on the top, and the C is gonna come here. So we can consider the 5 kilo ohms as R1 for now to make it easy. Alright, so now what we're gonna do is we're gonna move the dt on the other side now, which is gonna be like this. So which is gonna be like dt over R1C1. Alright, now we need to find V out 1, so we can do integral on both the sides. Since negative and R1C1 are constants, we can just move them outside the integral, and this becomes like this. Alright, now integral and derivative are opposite, so we're gonna get V out 1, and then we know Vi is 10, so if we come to write like this, integral of 10, since it's a millivolt, so we can write like this, U of t dt. So now this is also a constant, right? So we can move this out. With a negative in the front. Over R1C1 integral of U of t dt with the limits 0 and t. Alright, so it's going to be like this. Now if you plug in all the numbers like R1, C1, and then solve it, this is going to come out to be V out 1 equals to
negative 0.5 volts U of t, and then if you solve the integral, then we know like integral of dt. So you can move the U of t out as well. So the integral of dt is just t, right? And if you put the limit t and 0, it's going to be just t. So we'll write just t here, right? And that's all. That's all you do for V out 1. Alright? So these are V out 1. Now we have to find B. So B is pretty similar to A part. So we all know that this is 0, this is 0, this is 0, just like here. Alright? The current is moving in this direction, this direction. This is going to be IC2. Alright, so we're going to do a KCL again. We can consider this as a B. Alright, so KCL B. And we're going to do the equation. So I'm going to do it similar to KCL A, right here. So this is going to be negative V out 1. V out 1 over 1 mega ohms, which is this one. And then we're going to do plus IC2 equals to 0. Alright, now we know IC2 is again V out 1 over 1 mega ohms. Plus, and now IC1 was CdV C1 over dt, and this is like capacitor 1. So now here it's going to be C2 dV C2
over dt equals to 0. Alright, we got this equation. And now similarly, just how we isolated dV out 1, we can do for dV out 2. Alright, so if we do that, then we're gonna get something like this. Like this, okay? So we're gonna get, instead of we're gonna get V out 1 over R2. R2 is basically like this one, 1 mega ohms. Alright, R2 C2 is basically 5 mu f, and then C2 plus, oh no, not plus, sorry, dt. Alright, we're gonna get this, and then we're gonna integrate both the sides. This is gonna be 0 to t, just how we did here. Alright, so now we're gonna get V out 2 equals to negative 1 over R2 C2 integral, and then again V out 1 t dt. So now if you solve all this, the final answer for V out 2 is gonna be 0.05 t square U of t dt. Not dt, my bad. U of t volts. that's how you do A and B part. Thank you.